Hello everyone, it's Miss Davis. Today we're going to do our 7.4 notes over applying the properties of similar triangles. So we need to start with our I will. It says, I will use the properties of similar triangles to solve for segment lengths. Okay, so at this point, if you need to pause me so that you can write this down, please do so. Okay, the next thing that we need to do is to do our theorems. And we have 3 different theorems here. Okay, our first theorem is called the triangle proportionality theorem. And it's if a line parallel to a side of a triangle intersects the other 2 sides, then it divides those sides proportionally. Okay, I'll explain what this means as soon as you get this written down. You need a sticky, or if you don't have your stickies from your teacher or at home, then just write the theorem down and then write what's underneath. So go ahead and pause me for now so that you can write this down. Okay, let's see what this actually means and apply it. All right? Okay, so here we go. Underneath, here is a descriptive of what we're talking about. All right? It says if a line is parallel to just one side of the triangle, then it cuts the other 2 sides proportionally. Okay? So EF is parallel to BC, therefore AE is proportional to EB, just like AF is to FC. So we write our proportion just like this with the 2 ratios. Okay? Let's try and do an example with these. All right? Okay, so let's see what we have. We have this down here on the bottom. Once again, if you need to pause me so that you can go ahead and write it down. Okay? All right, so here we have a triangle where NP and RS and Q. So we have triangle NQP. All right? And this right here, and you actually need to see this. These 2 are parallel. Okay, so you should be given the arrows there. So we have to find out what is RQ. So I'm going to put a little X there so we know what we're looking for. Okay, so now all we got to do is set it up just like it was up there. So let's do, I'm going to do 6 to 7. Okay, I kind of like sticking to one side and then doing the other. 6 to 7 is 2. Now go straight across in the 6, 12 to X. So now using the cross products like you learned on Friday, we are going to solve for X. So here, 6X equals 84. X equals 12. Oh, nope, see I didn't do my math right. X equals 14, pardon me. Now, is that the question they asked? The answer is no, we still haven't answered it because they want to know what RQ is. And oh, looky there, yes we did. X is 14, so yes it does. So we can just say RQ, and we're talking about an actual length now, so we don't put the little line above it. RQ equals 14. Okay? Not too bad. All right. Let's move on to our next one. If you need to pause this right now so that you can go ahead and get all this written down, then please do so. Okay, let's move on to the next theorem we have. All right. This one is called the converse of the triangle proportionality theorem. Okay, so this is the converse of what you just learned on this theorem. Okay, it says if a line divides 2 sides of a triangle proportionally, then we know it to be parallel. Okay, so let's see what that says. But first, go ahead and pause the video so you can make sure you get this written down on your sticky note or on your notebook. All right? All right, welcome back. Let's go ahead and see what this means. Okay, due to a diagram, this is what it's representing. Okay? It says that if, this is the case, if AE to EB is the same proportion as AF is to FC, then this line EF has to be parallel to BC. Okay, so let's try that and practice it, okay? So here they're saying show us that these 2 lines are indeed parallel. Well, we need to set up our proportion and see if it's the same. So let's do 18 to 45 equals 6 to 15. Okay, do they reduce the same? Well, let's see here. We have, if we do 9, 9 goes into that one 2, 9 goes in 5, and these are both divisible by 3, so 6 divided by 3 is 2, 15 by 3 is 5. They are indeed the same ratio. So yes, they are parallel lines. Good. All right, we just have one more theorem to do, and that is this one, the triangle angle bisector theorem. Okay? All right, I'm going to reposition there a little. Okay, so this one says, an angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Okay? So what I need you to do now, as you know, go ahead and pause me, write this all down, and then we'll look at a diagram of it and then a problem. Okay? All right, let's see what we can do now. All right, this is the diagram description. Once again, it's showing you a triangle with an angle bisector. Okay, this angle's been bisected. And since that's the case, now we know that BD to DC is the same proportion as AB to AC. Okay, so let's see here on this example. Right here, they're asking us to find what is EF and FG. What are they? What are their lengths? So let's see, according to our example, we do the bottom. So let's do x over x plus 2, proportional to, let's see, 8 goes with x, so 8 over 12. Okay, now let's cross multiply, so we get 12x equals 8x plus 16. I'm going to subtract 8 from both sides, so I have 4x equals 16, and divide by 4, so x equals 4. Can you see that? Now, that actually does answer the length for EF, but what about FG? Okay, so here we need to go up and we need to say EF, remember, once again, giving a length so we don't put the bar above it. EF is 4 because it was just x, and FG is actually 6 because it's 4 plus 2. Okay? So those are our answers for this one. All right. Well, there you go. There you have it. Your 3 theorems for section 7.4. Okay? If there's anything you need to go back and make sure you have a copy of, please do that. Make sure you've got all the answers written down, and we will go over several more examples on on Tuesday in class, so that you can make sure you are understanding these. All right, guys, if you have any questions at all, please feel free to email me or Miss Scott, and we will see you tomorrow in class. Have a good one.